We want to express 5 cos x minus 12 sin x in terms of r cos x plus theta for r is greater than 0 and theta between 0 and pi by 2. Now, just make a note, theta is between 0 and pi by 2. That wants us to use radians. Don't throw silly marks away by putting your angle in degrees. So we have 5 cos x minus 12 sin x. That's going to be equal to r, and then using the expansion for this, cos x cos theta minus sin x sin theta, which we can write as r cos theta cos x, take away r sin theta sin x. By comparing coefficients, we can see that r cos theta is equal to 5, and just here we can see that r sin theta is equal to 12. R is going to be the square root of 5 squared plus 12 squared, which is 13. And then dividing here, we get r sin theta over r cos theta is 12 over 5. The r's cancel, and then we have tan theta is equal to 12 over 5. So theta is going to be the inverse tangent of 12 over 5. So we can calculate that. Now it's always a good idea to take this out of complex mode. And we're in radians, which is good. So we want the inverse tangent of 12 divided by 5. And it's probably best to be in decimal. And that's 1.176 radians. And so we can say 13 cos x plus 1.176 radians. Now just note here that I've put a C for circular measure, but you don't have to put any sort of symbol at all for radians. Radians are just numbers, so it's perfectly acceptable to just put 1.176. Hence solve 5 cos x minus 12 sin x equals 6.5 for x correct to 2 decimal places on the domain negative pi to pi. Note it's only 2 marks. What we should do to show the hence part is replace this with what we found in the first part of the question. So 13 cos x plus 1.176 is equal to 6.5. Now I can see this is going to work out easily, but this is 2 marks. You could just do this on the calculator at this point. But I'm going to go ahead. 6.5 divided by 13 is a half. So my principal value for x plus 1.176, inverse cos of a half, we know is pi by 3. So that one's here. And the secondary value for cos will be down here, negative pi by 3. So x plus 1.176 is equal to pi by 3 or negative pi pi by 3. So let's do pi by 3. And take away 1.176, and that gives us negative 0.129. And then negative pi by 3, so we could just make this one negative here. Negative 2.23, and both of those are within range, and it was supposed to be to 2 decimal places, so x is negative 0.13 or negative 2.23. This was the calculator paper, and it's only 2 marks. So right back here where we first substituted, we could then have solved. So that's 13 cos x plus 1.176 is equal to 6.5, given, and we wanted to be between negative pi is less than or equal to x, which is less than or equal to pi, and negative 2.23 and negative 0.13. Write down the equation of the function graphed below. Well, it goes this way. I know that the tangent always goes that way, so this looks like a cot. So I'm going to start by writing down cot. Now the period of a cot is pi, and I can see the distance between the two asymptotes here is pi, so it's going to have an x here and not a 2x or a 3x or anything like that. Now I can see, looking at it, that it crosses the axis here, and that seems to be the inflection point, and that tells me that it's not been moved up or down in any way, so that's not happened. And also it's 1 pi by 4 before the inflection point and negative 1 pi by 4 after it, which tells me that it's not stretched in this direction either, so there's nothing in front of the cot. But the asymptote is at pi by 4, and normally for the cot the asymptote is the y-axis, so we've moved it to the right pi by 4. So that's the correct transformation. Now we're given the points a, 1, negative 3 and b, 4, 1, and we want to find the unit vector parallel to the vector AB. Now to find AB, you can do b minus a, or just simply look at what you need to do to go from the point A to the point B. So doing it this way, we have 4, 1, take away 1, negative 3, so that gives us 3, 4. If we look at this way, we're going from 1, negative 3 to 4, 1. So x coordinate of 1 across to an x coordinate of 4 means 3 across. And then an x coordinate of negative 3 going up to 1 means it's 4 up. This is a right angled triangle, so it's clear that this is 5, the magnitude. So we're just going to have 1/5 of 3, 4. And that makes it a unit vector because we're dividing by the modulus. Now we want to find a vector of magnitude 10 that's parallel to the vector AB. Well, this one's a unit vector, so it's got a magnitude of 1 and it's parallel to AB. So we'll just do 10 times 1/5, 3, 4. Cancel here, and that's twice 3, 4, which we can easily write as 6, 8. Find the angle the vector AB makes with the positive x-axis. Remember, the x-axis goes this way, so is in the direction 1, 0. We know that A dot B is equal to the modulus of A times the modulus of B times the cosine of the angle between the vectors. And we know that AB goes up here, 3, 4. So we want this angle just here. So that's going to be 3, 4 dot 1, 0 equals 5 times 1 times cos theta. So this is going to be 3 equals 5 cos theta. So cos theta equals 3/5. And then theta is going to be the inverse cosine of 3/5. And we can work that out. It's probably normal to give this in degrees, but it doesn't actually say, so you could give it in any unit. So I'm going to give it in degrees. So go to trig, inverse cosine of 3/5. And that's 53.13 degrees.